So whenever we throw trig into calculus, I think a lot of students really struggle with it because they find trig to be confusing and there's a lot of patterns and stuff, and it just, I don't know, it makes things harder for some people. I'm one of the weirdos who loves trig, so I throw it in a lot in my problems in class. But we're just going to break it down into basics here. So we already know how to integrate a lot of trig functions, right? There's a lot of things that are very straightforward patterns from our derivative knowledge. Right, so we know that the integral of cosine of x dx is equal to sine of x plus c. Okay, so that's easy to do, right? We know the integral of sine of x, right, is just negative cosine of x. We know that the integral of secant squared of x, right, is tangent of x. Right, we know that the integral of secant tangent of x, right, that's just secant of x. Right, so basically as long as it fits a normal derivative pattern, we know how to take the derivative of it. But we don't even know right now, right, some things that are missing on this list is that we don't know how to integrate some basic trig functions, right? They have to fit these very specific patterns. Right, so we know these, but say, right, we put something like this on the list, right? What's the integral of tangent, right? So if you're trying to think about it in terms of like normal integration, anti-derivation, right? We know like, okay, like what function would I take the derivative of to get tangent back? So you might not be able to come up with it automatically off the top of your head. So, right, so let's just go ahead and do it. So the thing with trig is that you have to pay attention to all of those basic identities, right? So knowing our reciprocal identities, knowing how to break down functions with Pythagorean theorem identities, double angle formulas are sometimes super helpful. Other than that, those don't pop up too much in calculus, like other than that, like half angle and stuff like that. So, right, if we rewrite tangent, right, as its definition, right, tangent is just sine of x over cosine of x. And this is always a great idea if you're totally stuck with trig, is just rewrite everything in terms of sine and cosine and see what happens. Okay, so now if we do it this way, we have this nice little fraction. If we let u be the denominator, cosine of x, right, our du is equal to negative sine of x dx. So if I make the du negative, I get positive sine of x dx, which is exactly what's left in the numerator. Right, so I can rewrite this to be the negative integral, right, of du over u. Okay, so that's just the negative, the natural log of the absolute value of u plus c. So if I plug in my u, right, that's just the negative natural log of cosine of x plus c. You can also think about this if you wanted to get rid of the negative, right? If you have a number in front of a logarithm, right, you can move it inside as an exponent. And if I take cosine to the negative first power, I can also make this the natural log of the secant of x. Since the negative 1 exponent just makes it a reciprocal. Okay, so now we have another one to add to our list. Right, so now this is the negative natural log of cosine of x plus c. Right, so based off of that, right, if you wanted to say do the integral of cotangent of x dx, right, it's really similar, except it's just going to be opposite, right, totally opposite because they're reciprocal functions. So it's actually going to be the positive natural log of sine of x dx, not dx, right, plus c. Okay, so now we know those two, but the other two singular functions that we haven't looked at yet are secant and cosecant, and their proofs are really similar as well, but they involve a little bit more shenanigans and kind of like algebraic manipulation. So we're going to go through the proof of how to do the integral of secant of x, and then it's basically the same thing to do cosecant of x. So if you want, you can go ahead and prove that on your own. So we're going to add that in here. Move that down. So we're going to prove two more today. We're going to add the final two. Trig functions to our kind of integral list, right? It's getting a little long there, right? Can't even fit it all on one page. Okay, so jumping down here. All right, let's figure out how to integrate this. Right, so we could try and rewrite it as 1 over cosine of x, but if we make a u substitution on cosine of x, right, there's no sine of x to balance it. So one thing that we want to get involved here is possibly using maybe our Pythagorean identities. So this is a little tricky, and honestly, if I didn't already know this, I probably never would have come up with it on my own, so I'm not expecting you to have either. We're going to do this little trick of multiplying in and dividing by something at the same time. Right, I know it doesn't make sense right now, like why you're doing that, but just hear me out, just follow along. Right, so if I multiply through in the numerator, I get secant squared of x plus secant tangent of x. Right, all over secant of x plus tangent of x dx. Okay. Now you might be thinking, why? Why would she do that? Like, why is that going to be helpful? Well, now that we have this fraction, if I go ahead and make a u sub with the denominator, if I take the derivative of my u now, my du, well, the derivative of secant is secant x tangent x, and the derivative of tangent is secant squared of x. All right, I'll throw dx there on the end. Right, so this perfectly takes care of the numerator now. And then the u takes care of the denominator. So now we can rewrite this to be du over u. And we know that that becomes the natural log of u plus c. So this is going to become the natural log of the absolute value of secant x plus tangent of x, all plus c. Right, so secant x, this nice little function, right, it actually has this really big antiderivative. Not super big, but like we got a plus sign in there, so it's bigger than the other ones. And right, you would do the same sort of algebraic trick for proving what the derivative of cosecant is. I mean, not the derivative, the integral. It's just going to be opposite, so it's going to be negative the natural log of cosecant of x plus cotangent of x, all plus c. All right, so there you got your final list of all of your trig integrals, which I can't even fit them all in here, really. Oh, kind of.